So this is our problem, which is a particle is moving in a straight line, so that is the position function. This is a function. They are asking us to calculate the derivative of the position function using the limit definition. B. Calculate the x-intercept and y-intercept of the position function. Graph the function. C. Calculate the tangent line, in an equation at the point P 0 minus 6. And D. Calculate the velocity of the particle after 2 seconds. E. When will the particle stop at the time interval of this?
First, we calculate the derivative using the limit definition, that is, limit of h that approximates to 0 is equal to f of x plus h minus f of x over h. Then we get a cubic and a quadratic, and we resolve it and factorize it. After that, we eliminate and get the common factor of h. We simplify the h, and finally substitute h with 0. The derivative is 3t squared minus 12t plus 12.
Calculate the x-intercept and y-intercept of the position function. This is our function, t3 minus 6t squared plus 11t minus 6 equal to 0. We first need to factorize this function with the factor term. We are going to use the number 1, t is equal to number 1, because we see it in the graph. We have to put the values of 1, minus 6, 11, and minus 6. We obtain a 0, so this t equal to 1 is a factor. Then, from this, we get a new function that is t squared minus 5t plus 6, and then we factorize this new function in t minus 3 and t minus 2 equal to 0. T is equal to 3, t2 is equal to 3, and t3 is equal to 2. And these are the x-intercepts. In y-intercepts, this is the x-intercept, and next we are going to do the y-intercept. We have to evaluate the original function with a 0. So 0 cubic minus 6 0 square plus 11 0 minus 6. This is going to give us a minus 6 because we eliminate all the values because of the 0. Finally, we get a y that is equal to 6.
For the graph, we have a cubic function with x-intercepts in 1, 0, 2, 0, and 3, 0, and y-intercept in 0, minus 6.
So this is our problem, which is a particle is moving in a straight line, so that is the position function. This is a function. They are asking us to calculate the derivative of the position function using the limit definition. B. Calculate the x-intercept and y-intercept of the position function. Graph the function. C. Calculate the tangent line, in an equation at the point P 0 minus 6. And D. Calculate the velocity of the particle after 2 seconds. E. When will the particle stop at the time interval of this? Our slope will be 11 because this eliminates and this eliminates. And then we do the point slope, which is this formula. So from here we want to get the slope, so we're going to pass this down here. and then it will be 11, our slope is 11, equals to y minus 6, which is y, over x minus 0. So we got this result, and after this we're gonna pass this to here. So it's gonna be so we're gonna do it again, and it's gonna be, we multiply this goes out, the x no, just the 0, and then it's gonna stay like this. Then they are asking us to calculate the velocity of the particle after 2 seconds. So we have our derivative, which is and then we're gonna substitute all the values of t for 2 seconds, and it's gonna stay like this. After this, we multiply, and it's gonna stay like this, and our final answer is gonna be minus 1.
When will the particle stop at the time interval t, 0 and 2? We first have our derivative, that is 3t squared minus 12t plus 11 equal to 0. In this case, we have the x equaling to t. We need to use the general formula, square b squared minus 4ac over 2b. We need to substitute the values of the function in the general formula. Continue resolving the general formula, 132 over 6, and continue to get two values, that is gonna be, and we have to factorize the number 2 in the formula, over 3, and the new function is going to be 6 plus minus 3 over 3, and this is going to divide in 2. T1 is equal to 6 plus square root 3 over 3, that is equal to 2.58, and T2 is equal to 6 minus square root 3 over 3, that is equal to 1.42 seconds. This is the result that we have to use because it's inside of the interval 0 and 2.